Good morning all. Welcome to this lecture series on foundation engineering. This is part 1 of lecture 1 on foundation on expansive soil. I am Amit Chauhan, head of civil engineering department, Lakshmi Institute of Technology, Sarigam. Welcome you all. These are the course content in which we'll start with introduction on expansive soil, following the mechanism of swelling, then identification of expansive soil by using different tests, then treatment of expansive soil so that we can use such soil for different structures, and following the last point, that is foundation on expansive soil. Let's see what are expansive soil. Expansive soils owe their characteristics to the presence of swelling, clay, minerals. As they get wet, the clay minerals absorb water molecules and expand. Conversely, as they dry, they shrink, leaving large void in the soil. That is, when the expansive soil is exposed to moisture, they behave in swelling condition, and when the amount of water is desiccated or evaporated from the soil, there is shrinkage in the soil. Expansive soil have minerals like Eulenite, Elite, Montmorillonite that are capable of absorbing water. Means these are the minerals which can absorb the water in case of clay soil or any kind of expansive soil. The expansive soil has considerable strength in dry state, but the strength goes on reducing on absorption of water. The soil exerts considerable pressure on foundation during swelling. This is very important. The black cotton soil in its natural state is having a considerable strength, but as the amount of water present in the soil fluctuates, that is, if the amount of water increases, it swell, and when the amount of water inside the soil decreases, it shrinks. In India, these expansive soil are known by local names such as black cotton soil in central India, bentonite in Rajasthan and Kashmir, mar or kabar in Uttar Pradesh. These soil occupy about 30 to 40% of the land area of India. Engineering structures constructed on expansive soil are subjected to highly detrimental behavior of such soil, leading to their damage and cracking. In that, foundation is the lowest load bearing part of engineering infrastructure such as building and dams, typically below ground level. Means not only the lower structure, that is your foundation, is affected because of expansive soil, but the ground beam or the ground slab or the exterior wall, even the interior wall, are affected because of the swelling property or shrinkage property of the black cotton soil. In India, igneous rocks like basalt in alkali environment in the presence of magnesium ions and absence of leaching forms the expansive soil. Basically, weathering of igneous rocks like basalt leads to formation of your expansive soil. The thickness of soil stratum can be high as 3 to 10 meters. The climatic regions like seasonal rainfall and high evaporation with little leaching have more amount of black cotton soil. This is the most comfortable condition for black cotton soil to form. That is the area which is having a seasonal rainfall only, and there is high amount of evaporation with little leaching. Areas like Arunachal Pradesh, Maharashtra, Karnataka, Tamil Nadu, Bhopal and some other places have such kind of soil. Leaching is available mostly in the areas of heavy rainfall. Such places don't have black cotton soils. Area which are having good amount of rainfall and the amount of leaching or infiltration inside the ground is more, that part is not having that much amount of black cotton soil. The damages occur due to swelling and shrinkage behavior of such soil, since the structures built on such soil get lifted up during rainy season due to heave of the foundation soil and settle down during summer season due to shrinkage of the foundation soil. That is based on climatic conditions. In case of monsoon season, there will be more amount of moisture addition in the soil that will swell the soil, leading to the heave of the foundation. And in case of summer condition, there will be desiccation or evaporation of soil water from the soil that leads to shrinkage of the foundation soil. Due to this uplift and settlement, The structures, particularly the lighter one, gets damaged and cracked if are not taken to prevent lifting of the structures. That if proper care is not taken, there is total possibility that the structure might experience uplift because of swelling characteristic and settlement because of shrinking property of the black cotton soil. Now, which are the various problems associated with expansive soil? When expansive soils are present, they will generally not cause a problem if their water content remains constant. Means there will be no problem if there is no moisture variation in the soil. But if the situation where greatest damage occur is when there are significant or repeated moisture content changes, that is if the amount of water variation is more or wetting or drying cycle is more, that part is more prone to what? Your swelling property of black cotton soil. Expansive soil usually won't have problems with heavy structures, but with light structures and pavement significant changes can be observed. Means in case of light structures and the pavement kind of structures, they are more susceptible to experience the shrinkage and swelling property of black cotton soil. Based on swelling and shrinking properties of the black cotton soil, the cost of construction on such soils can be more. Means if the amount of money that needs to be spent on the treatment of black cotton soil can affect that overall cost of the construction. The equilibrium water content is not same below the foundation. This leads to differential settlement and diagonal cracking of masonry superstructures. Means what? This means if there is more amount of water variation below the underground level, that can lead to differential settlement and diagonal cracking of the interior wall as well as your exterior wall, because the water content below the ground is not equal at all the point around a same structure. In case of a same structure also, there can be moisture variation at different point, and based on that moisture variations, the foundation may experience different settlement, which leads to differential settlement of the superstructure. Now, based on these kind of property of black cotton soil, it is always assumed that the bearing capacity of black cotton soil is low. The correct estimation of allowable bearing capacity of black cotton soil is correlated by using various factors such as swelling pressure, groundwater table variations, site conditions, amount and kind of clay mineral present, etc. So these are the factors which can influence the bearing capacity of black cotton soil. This leads to assumption of lower bearing capacity of black cotton soil. But if the probable swelling is higher than the assumed bearing capacity, the foundations are subjected to differential settlement. Cracking of single-storied building is very common than that of double-storied building that we have already discussed. Now, which are the different reasons for the variation of soil moisture in case of black cotton soil or any kind of area which is experiencing more amount of variation of water content? The detrimental behavior of the expansive soil, as stated above, is primarily caused by the variation of water content in them. Since with the intake of water they swell, while with the removal of water they shrink. The study of the variation of water content with season and with depth therefore becomes important in the study of their behavior. This study shows a typical pattern of water content as shown in the figure 1. So this is the figure which shows you the variation of water content in case of summer season or in case of monsoon season, and what is the general water content in case of any kind of soil. On x-axis we have increasing moisture content of soil, and on y-axis we have increasing depth. The line 1 shows you the equilibrium moisture content over a covered area. So this is the line which shows you the change in water content on a covered area. Line 2 show you the desiccated moisture content, which is based on the uncovered natural conditions. Means the ground which don't have any kind of structures built on it. Line 3 gives you the wet season moisture content, which is in case of monsoon season, where the amount of water depleting on the surface is not that much. Means the unstable depth in case of monsoon season will be less. Unstable depth is that depth, up to that depth there will be not much water content variation, which can be seen by the line given by DUS. DUS stand for unstable zone in case of general other kind of seasons other than your monsoon season. Let's see. Variation of soil moisture. It can be seen from that during summer season the natural water content is practically zero at the surface and reaches maximum in the rainy season. However, the water content remains practically constant beyond at depth DUS, called the unstable zone depth. The depth of unstable zone DUS is an important factor, since it is this depth in which the soil is subjected to drying and wetting, undergoing considerable movement. That is, up to the depth of DUS there will be continuous changing in water content. Sometime it will be dry, sometimes it will have a good amount of moisture, and based on that the soil, this will experience continuous alteration. That is, sometime it will shrink or sometime it will swell. Now, which are the different reasons for the causes of moisture change? Moisture change can be due to natural process or due to human activities. Some of the common causes for the moisture changes are as follow. Moisture changes may occur due to change in the water table. The water table in the surrounding can be changed because of climatic condition or temperature condition, anything. Moisture may increase due to landscaping and irrigation of lawns and kitchen gardens around the building. Means if the surrounding is having more amount of irrigation activities going on, or there are more kitchen gardens around the surrounding, then the possibility of moisture change will be more. If the vegetation around the building is removed, that is, if the land cover is changed, the transpiration will stop and the moisture will increase. If the surface water drainage become defective and the runoff is obstructed, the water will infiltrate the ground and cause moisture change. Means if the amount of infiltration is increased because of any problem on the ground surface, that will lead to the increment in the amount of moisture in the soil. Moisture changes may occur due to seasonal changes if there is a large variation in temperature in different season. Some part of the countries experience such kind of seasonal changes very abruptly. If a slab or a pavement is placed directly on the ground, the direct evaporation of water is stopped. Moreover, direct infiltration of rainwater is prevented. Now let us see what are the swelling and collapse behavior of a black cotton soil. Collapse and swelling phenomena occur in unsaturated soil during the saturation process. That is, the soil which are unsaturated, which are having voids which are not filled by water. If they are filled by water because of some means, the possibility of swelling will be more. The compacted unsaturated soil on the dry of optimum have open structure and are more vulnerable to drastic volume change upon saturation. Two distinct volumetric response may be observed upon. Now this is very important. Two distinct volumetric response may be observed upon wetting of such soil based on the stress level in the soil. The stress level can be of two type. First one is swelling of the soil occurs under low normal stresses during the wetting process, and second one is, on the other hand, sudden decrease in volume followed by a gradual swell will be observed under the high normal stresses. The sudden and significant decrease in volume is referred to as volumetric collapse, a common phenomena in case of marine environment. Now let us see what is the mechanism of swelling. The mechanism of swelling depends on the type and amount of clay minerals present in the soil. which are the different clay minerals: kaolinite, illite, and Montmorillonite. Now, based on the amount of kaolinite, illite, and Montmorillonite, the capacity of cation exchange, that is CEC, is a measure of how many cations can be retained on soil particle surfaces. Negative charges on the surface of soil particles bind positively charged atoms or molecules, that is your cations, but allow these to exchange with other positively charged particles in the surrounding soil water. Means there is exchange of positively charged particles between water and the other charged particle, which is done by whom? Which is done by the negative charge of the soil, but allow these to exchange with other positively charged particles in the surrounding soil water. This is one of the ways that solid particles in soil alter the chemistry of the soil. So these are the reasons which is altering the chemistry of the soil, and which is the main reason for the expansive nature of the black cotton soil. CEC affects many aspects of soil chemistry. Cation exchange capacity is defined as the amount of positive charge that can be exchanged per mass of soil, which is usually measured in centimole per charge per kg of soil sample. Some texts use the older version of unit, which is called as equivalent unit, ME per gram, which can also be represented in MEQ per 100 gram. CEC is measured in moles of electric charge. Now let us see what is kaolinite. Kaolinite is one of the mineral present in your clay. Kaolinite is a clay mineral, part of the group of industrial mineral with the chemical composition of Al2Si2O5OH4. It is a layered silicate mineral with one tetrahedral sheet of silica linked through oxygen atom to one octahedral sheet of alumina. Kaolinite is basically a layer of silica with combination with a layer of alumina. Rocks that are rich in kaolinite are known as kaolin or china clay. The bond between the two sheets is strong. Means this silica and alumina sheets both are having a very strong bonding with them. The bond between the two sheets is strong and the mineral is stable. Water cannot easily enter between the structural unit and cause expansion, hence less swelling on wetting. Means because of this strong behavior between silica and alumina sheet, they don't allow water to penetrate inside between the bonding between them. Because of this, kaolinite is having very less possibility of swelling. Kaolinite has a low shrink swell capacity and a low cation exchange capacity. So basically this CEC, cation exchange capacity, describe the swelling property of your clay mineral. As kaolinite is having less CEC, it is having low swelling property inside it. It is a soft, earthy, usually white mineral produced by the chemical weathering of aluminum silicate minerals like feldspar. Means if feldspar is weathered, we'll get more amount of kaolinite. In many parts of the world, it is colored pink, orange, red by iron oxide, giving it a distinct rust hue. Lighter concentrations yield white, yellow or light orange colors. Commercial grades of kaolin are supplied and transported as dry powder, semi-dry nodule or liquid slurry. Below 100 degrees Celsius, exposure to dry air will slowly remove liquid water from the kaolin. The end state for this transformation is referred to as leather dry. Means if the temperature of the kaolin is below 100 degrees Celsius, the end product which will get is known as leather dry. If the temperature of the kaolinite is between 100 degrees Celsius and about 550 degrees Celsius, any remaining liquid water is expelled from kaolinite. The end state for this transformation is referred to as bone dry. Throughout this temperature range, the expulsion of water is reversible. Means water can, if we add water to kaolinite, it can again accept that water. If kaolin is exposed to liquid water, it will be reabsorbed and disintegrate into its fine particulate form. Subsequent transformations are not reversible and represent permanent chemical changes. It is not always possible to get the same product, but it is possibility if you'll add water to kaolinite in this range of temperature, it will again accept the water. Now let us see what is metakaolin. Metakaolin is basically a clay mineral which is used extensively in case of soil engineering based projects. In endothermic dehydration of kaolinite begins at 550 degrees Celsius to 600 degrees Celsius. Means if the temperature range is 500 to 600 degrees Celsius, producing disordered metakaolin but continuous hydroxyl loss is observed up to 900 degrees Celsius. Although historically there was much disagreement concerning the nature of the metakaolin phase, extensive research has led to a general consensus that metakaolin is not a simple mixture. Means metakaolin is not very simple to handle and it is very unstable. Now let us see what is Montmorillonite. Montmorillonite is very soft phyllosilicate group of minerals that form when they precipitate from water solution as microscopic crystals known as clay. Montmorillonite, a member of this pectide group, is a 2:2 clay, meaning that it has two tetrahedral sheet of silica sandwiching a central octahedral sheet of alumina. Means it is a layer of what? Silica, alumina and again silica. Aluminum is sandwiched between two silica sheets. The particles are plate shaped with an average diameter around 1 micrometer and a thickness of around 0.96 nanometer, magnification of about 25,000 times. Using an electron microscope is required to see individual clay particles. Means they are so small in size. For that we need a electron microscope to see these clay minerals present in the soil. Montmorillonite is having greater than 50% octahedral charge. Its cation exchange capacity is due to isomorphic substitution of Mg for Ai, that is magnesium is replacing your alumina from the silica alumina sheet. In the central alumina plane, the substitution of lower valence cations in such instances leaves the nearby oxygen atoms with a net negative charge that can attract cations. Means when these magnesium's ion are replacing your alumina ion from the silica sandwich layer, the possibility of attracting the positive ion increases. The individual crystals of Montmorillonite clay are not tightly bound, hence water can intervene causing the clay to swell. The water content of Montmorillonite is variable and it increases greatly in volume when it absorbs water. The cation exchange capacity of Montmorillonite is very high. Because of that, the Montmorillonite is having the most amount of swelling property. Out of all the three minerals, that is kaolinite, illite and Montmorillonite, Montmorillonite is having the most amount of swelling property in it. Now let us see what are the different uses of Montmorillonite. Montmorillonite is used in oil drilling industry as a component of drilling mud, making the mud slurry viscous, which helps in keeping the drill bit cool and removing drilled solids. Because of its more expanding and swelling property, it is not possible to use Montmorillonite in case of any structures, but based on its this kind of property, it can be used in other kind of applications. It is also used as a soil additive to hold soil water in drought prone soil, used in the construction of earthen dams and levees, and to prevent the leakage of fluids. Similar to many other clays, Montmorillonite swells with the addition of water. Montmorillonite expands considerably more than other clays due to water penetrating the interlayer molecular spaces and concomitant absorption of water. The amount of expansion is due largely to the type of exchangeable cation contained in the sample. As we have discussed that magnesium is replacing the alumina sheet. So based on what kind of ions are replacing the alumina sheet can give you the different kind of CEC. That is your cation exchange capacity. The presence of sodium as the predominant exchangeable cation can result in the clay swelling to several times its original volume. That is, in case of magnesium, if we are using sodium to replace the alumina sheet, the amount of possibility of swelling will be very much high. Hence, sodium Montmorillonite has come to be used as the major constituent in non-explosive agents for splitting rock in natural stone quarries in an effort to limit the amount of waste. That is the place where using explosive is banned, or the places where we cannot use the explosive. In that condition, we can use such kind of Montmorillonite replaced by sodium, which is called as sodium Montmorillonite, to break such kind of rocks. Or for the demolition of concrete structures where the use of explosive charges is unacceptable, we can use sodium Montmorillonite. Now let us see watery light. Light is a group of closely related non-expansive clay minerals. Light is a secondary mineral precipitate and an example of a pyrosilicate or layered alumina silicate. Its structure is 2:1 sandwich of silica tetrahedron, alumina octahedron and silica tetrahedron layers. The space between this TOT sequence of layer is occupied by poorly hydrated potassium cations, which are responsible for the absence of swelling. Means light is a sandwich layer of what? Silica tetrahedron, alumina octahedron and silica tetrahedron, which is called as TOT, and the layers between them is having a poorly hydrated potassium cations. Because of this poorly hydrated cations, the swelling property of light is very much less. The cation exchange capacity CEC of light is smaller than that of smectite but higher than that of kaolinite, typically around 20 to 30 milli equivalent moles per 100 gram. That is, light is having more swelling as compared to kaolinite, but it is far less than Montmorillonite. Thank you for listening to my lecture. I hope you like the lecture. Thank you.